This is the very first video on this sequence, and we thought that as a good place to start, we should take a look at fractions and what do they mean, what is the notation, and how do we actually combine them. So for this video, we are going to focus number one in notation and number two in basic arithmetic. So for notation, what we want to say is, what do we mean whenever we use a fraction? Like, what does it represent? And how can we think of it pictorially? And before we get into it, I want to say that the reason why we're doing this is because it seems like fractions have become quite an obscure portion of basic algebra. And in whatever it is that we want to do later, I want you to have this as a reference to come back and kind of see what's going on. So let's talk a little bit about notation. And to do this, let us present a task. Let's suppose that we want to divide the number 4 into 3 equal parts. All right. So if we wanted to do this, let's do a picture first. Let's suppose that I have 4 items, 1, 2, 3, 4, and I want to subdivide this into 3 equal parts. So I'm going to have 3 divisions, 1, 2, and 3, and this is where I want to place my numbers. So definitely I'm going to take this one here and bring it there, so I have 1. I'm going to take the second one and bring it here, so I also have 1, and then the third I'm going to bring it to the last one, and I also have 1. But then once you do this, you see that there is some left over, the last item that we have to deal with. What we do with this one is I'm gonna blow up this guy here, make it larger, and then what we're going to do is we're gonna subdivide it again into 3 equal parts. The first one is gonna come here, it's very little. The second one is gonna come here as well, and then the last one is gonna come into the third box. So what we see is that when dividing 4 into 3 equal parts, what you have is that each of these terms has an integer, and then there was one left over which you still have to divide into 3 equal parts, right? Alternatively, you could think of each of these numbers 1 and a third as themselves being subdivided into 3 equal parts, and if you do that, you see that each of these one has 4/3, right? And this guy here, this is our magical object. Like, what is the number 4/3? What do we mean by it? There is a lot of confusion that comes when looking at these objects, and the reason is because there is way too many notations for it. So the first way is in English, when you say divide 4 into 3 equal parts, what that means is that you're doing the division 4 divided into 3, or 4 divided in 3 parts. This is also the same as the statement, how many times does 3 fits into 4? And this is also the fraction 4/3, right? So this means that a third, we have it 4 times. This is also the notation 4 times 1/3. This is also 1/3 times 4. This is also 1 and a third. And this is, in this last notation, 1 and a third, what it really means is 1 plus 1/3. So I see where the confusion comes from, right? So there's too many ways to represent the same object. You can either say 4 divided by 3, how many times 3 fits into 4, 4/3, 4 times a third times 4, 1 and a third, 1 plus 1/3. And this one here is symbolic. What you see on the right is what it actually means. So I can agree with many people that when dealing with fractions, there are too many ways to represent them, and therefore some confusion might arise. Because of that, I'm going to exemplify the 4 basic operations of multiplication, division, addition, and subtraction, and I'm going also to set up like the different notation you can have for each and how to explore them. All right. So let's move on to basic operations. So number 2, basic operations. And here let's start by multiplication. As before, for multiplication, we have many ways to express this, and I'm not going to put them all here, but I'm going to show you a few of them, and then we'll choose the one that is more convenient, which is the first one. So here, the fraction a over b times the fraction c over d. If I want to multiply this, and in the literature, you can also see this as a over b times the fraction c over d. In other places, you do not have neither the times nor the dots. Instead, you can write the first one and the second one and close it into a parentheses. This is still multiplication. And you can also use, instead of just parentheses, you can also use close brackets, or you could also use curly brackets or keys. Either way, they're all fractions, and again, one can see where the confusion comes from because there's too many ways to represent just this one operation, and for that reason we will stick with the first one. So if I wanted to multiply two fractions, I'm going to take this one here and bring it over there. It's fine. If I wanted to multiply these two fractions, the rule to do this is that you multiply the two numbers on the top, and you also multiply the two numbers on the bottom. And after you multiply a times c, you place it on the top of your new fraction, and when you multiply b times d, now you place it in the bottom of your new fraction. So let me give you two basic examples. So let's do here example 1. You have the fraction 1/2 times 3 over 4. And if we want to do this according to a rule, we have to create a new fraction where the numerator is 1 times 3 and the denominator is 2 times 4. We know how much this should be, or we can use a calculator. 1 times 3 is 3 and 2 times 4 is 8. So this is my final answer. When you multiply the fraction 1 over 2 times 3/4, you get 3/8. And some people might be a little bit more advanced and see that this is the fraction 3/4 divided by 2, and this is how you get 3/8, and we'll see that in a moment. Let's do a different example, something that maybe simplifies. So here, let's multiply the integer value 6 times the fraction 5 over 2. So if I wanted to do this, now it doesn't look like the rule that I have up here because this is an integer times a fraction, and my rule works for two fractions. So what we do is we psychologically trick ourselves and think of 6 also as a fraction. So we're going to write it as 6 divided by 1. This is not the unique way to write 6 as a fraction, but it's one that works. And we multiply by 5 over 2. If we carry this computation according to our rule, now that I'm multiplying this fraction and that fraction, we need to do top times top, that will be here, and then bottom times bottom, and that will be down here. All right, so let's place our new fraction with 6 times 5 in the numerator and 1 times 2 in the denominator. The top is 6 times 5, which is 30. The denominator is 1 times 2, which is 2. And this, again, this is the same as how many times 2 fits into 30. So we can rewrite this just as the integer 15, right? And some other people might have noticed that this 15, one could have also attained it more quicker if you would say something like 6 and 2 have a common factor of 2. And after cancellation, you only have a factor of 3 to multiply to 5. So that's another alternative. All right, the second operation that we want to discuss is that of division. So how do we divide fractions, and how many different ways can we write this? So I'm going to give you two different ways of writing division. So the natural one will be the fraction a over b divided by the fraction c over d. And also, because we have here a number divided by a number, we can put this into a fraction according to our definition. So this will be the fraction where the number on the left will be the numerator, and then the number on the right will be its denominator. So we can write it as the fraction a over b divided by the fraction c over d. And the way that we actually compute the division of one fraction by another, it's by multiplying a over b times d over c. So you take the first fraction, you rewrite it, the division becomes a product, but then your second fraction, you have to flip it before you multiply. So it's a quick computation, so let's do two examples again. Let's do example 1. For this one, let's do 1 over 2 divided by 1 over 4. So notice in this case what we're doing is we're dividing the fraction 1 over 2 by 1 over 4, but we're also finding how many times 1 over 4 fits into 1 over 2. So according to our rule, we'll rewrite the first one, replace division by multiplication, and the second one will flip it, right? So 1 over 2 stays there, division becomes multiplication, and then your second fraction you have to flip. We use the rule for multiplication. This will be 1 times 4 over 2 times 1. 1 times 4 is 4, 2 times 1 is 2, and 4 divided by 2, or how many times 2 fits into 4, is just 2, right? So here we have a quick survey of how to multiply fractions, how to divide fractions. In summary, you multiply fractions to the side, so the tops get multiplied and the bottoms get multiplied. But when you're dividing fractions, you have to replace division by multiplication and take your second fraction and flip it. Then you multiply to the side, right? Because this is a rule for multiplication. Now I have left for last the operation that usually most people, let's call it addition. And this rule works both for addition and subtraction. This is the one that most people get confused on. And to discuss it, I'm gonna give you two flavors of the same thing. There are actually three cases one could develop, but let's boil it down to two cases. So the first case is when the two fractions have the same proportion. So let's call it same proportion. In other words, we're not going to add 1/2 and 5/3, or we're not going to add 1 over 7 and 10 to the over 13. We're going to take things that are divided by the same ratio or the same proportion, and we're going to combine them. So this looks like a number a over b, and then we want either to add it or subtract it to the number c over b. So both proportions are the same. When this happens, you can think of this as having similar objects, right? So you have a times 1 over b, and you have c times 1 over b. So this is like saying I have this many 1 over b's and these many 1 over b's, and I'm going to combine them. So in this case, we just add or subtract whatever is on the top and then keep the same proportion. So for example, if I wanted to do 2/3 plus 5/3, and I see that the two proportions are exactly the same, then I can say the proportion will stay, and I will just add whatever I had on the top. And in this case, this becomes 7/3. So notice that by adding 2/3 and 5/3, all you get is 7/3, because you're adding things with the same proportion. Now the other case that one can face many times, but the option that I'm going to offer here is not the only way to address it. It's when they differ, they have different proportions. But in this case, I'm going to give like a quick version of how to do it. So in this case, you want to add something that looks like a over b to another number. So you want to either add it or subtract the number c over d. So in this case, it's possible that b and d are different. And when b and d are different, your cases are either b is a multiple of d or not. And in either case, the formula that I'm going to write now, it works always. So here you're going to have a new fraction. The first term that we're going to place here into this new fraction is the product of a and d. So I'm going to place here the product of a and d. Whatever the symbol is that you have here, you have to repeat it. So this will become plus or minus. And then your second term will be b times c. So So we're gonna place here the number b times c. And finally, for our denominator, we're going to multiply the numbers in the denominator. So we're gonna have a common denominator of b times d. Right? So let's do an example. So let's take here 1/3 minus 2/5. So if I wanted to combine these two numbers, I will say that I will have a new fraction where the first term, whatever comes here, is the product of these two. So 1 times 5. In this case, we're subtracting, so I'm going to keep writing minus. And then I'm going to multiply 3 times 2 in this direction, so 3 times 2. And we also need to find out who is the denominator. In this case, you have 3 times 5. Right? So we can simplify a little bit. This looks like 5 minus 6 over, and here we have 3 times 5, which is 15. And this looks like -1 over 15. Now this number is negative, and the reason why this number is negative, we should observe, is that we are subtracting 2/5 from 1/3, but 2/5 is already much bigger than 1/3, so we expect this number to be negative. All right, so as a sum up, I'm gonna go upward and kind of travel through the things that we said. Today's video was in fractions. We have different notations for denoting the same fraction. 4 divided by 3, how many times 3 fits into 4, 4/3, and 1 1/3, or 1 plus 1/3. The basics operations are multiplication, where it's done towards the side. You multiply top times top and bottom times bottom. We have division, where you have to multiply the first fraction times the reciprocal of the second one, so you have to flip it. And we also have addition and subtraction, where in the case where the proportions are the same, we just add or subtract whatever the numerators are. And then if they are different, if these two numbers are different, and I want to find out what the summation should be, I just do these 3 multiplications. But always remembering that whatever it's in here is the symbol that you should place in there. All right, thank you so much. I'll see you next time.